In this video, we answer the essential question, how do I multiply monomials? And we've already defined a monomial as an expression with one term. So the question is, how do we multiply things together when there is a monomial in it? And so let's take a look at the first one. We'll start off easier and get a little bit more difficult as we go. The question here is find each product. When you see the word product, it means multiply. So product means multiply. And now we have a monomial being multiplied by another monomial. And you're going to follow, in this case, the basic math rules that you've learned in previous classes. You're allowed to multiply a little bit differently than the way you add and subtract. It's actually, in my opinion, quite a bit easier to multiply terms rather than add and subtract terms. So in this case, let's just talk about something mathematically. This particular question could actually be reordered. If you learned, well, you've learned this in previous classes, that multiplication is commutative, and that means you can move the terms around and the answer is going to be exactly the same. So that means we could actually write it this way. We could put the 3 here. We could take this like term, the 5, and move it right next to it. This little dot means multiply. And then we can put the x squared here. And then we can put the x here. Whoops, not an equal sign. That should be multiplied times x. So what I did was I rearranged this class so all the constants are in the front and all the variables are in the back. And I only have x's. If I had y's, I would have put the y's at the end of this. And here's what I want you to see. When you're multiplying, you can multiply, in this case, these are like terms. So 3 times 5 is 15. It's going to be equal to. This is 15. And then take a look at the x squared and the x. Now what's different about multiplication is you're allowed to multiply variables together as long as it's the same variable. The exponent doesn't matter anymore. So you couldn't combine these together if you were adding or subtracting them, but you can combine them together when you're multiplying them. What I want you to just think about is x squared times x, and let's put a little notation here so you remember this. X squared times x is really just x times x times x. Well, x squared is x times x, and then we just multiply another x. So x squared times x is x times x times x. So you can see x times x times x is x to the third. And the way normally this is written, and let me move this up a little bit so we get a little bit more room here. The way this is written is, let's say this is equal to 15. Mathematically, this is equal to 15x to the squared, x squared, and then we add the other exponent together. We've got x times itself, and we're multiplying by x again. That's x to the 2 plus 1 power. And if we finish up this answer, let's do this a different color so you see it. This would be equal to 15x cubed. 15x cubed. I'll circle my answer so you see that's the end. And that, I don't like that 3 doesn't look very clear to you, so let's go ahead and rewrite that. 15x cubed. Again, remember, when you multiply the two variables, the same variables together, and they have different exponents, all you do is add the exponents together. Let's do another one so you can see this happen again. 8xy, that's a monomial, times 2y squared x to the fourth, that's a monomial. Let's go ahead and multiply these together. I'm going to go ahead and reorder these terms. Let's put the constants in front. Now I'm going to put all my x terms next. We've got an x, and we've got an x to the fourth, and then we have a y, and we have a y squared. As before, I won't do this right now, class, but sometimes when I get really complex monomials, I'll go ahead and cross off the terms as I write them to make sure I get them all. We got an x, an 8, a 2, x to the fourth, y squared. We're good to go. Alright, so you can see here, and actually, you know what, let's put a little underline here to show up at the top that we were able to combine those two together. Alright, so now let's go ahead and start doing some simplification. 8 times 2 is 16. x times x to the fourth is x to the first plus the fourth. And another thing I want you to note is, I didn't say this before, but x is the same thing as x to the first. So I could put a 1 here. In this case, I could put a 1 here, and I can put a 1 here. Y and y to the first are the same thing. It just means y, and that's it. Not being multiplied by anything else. So these two terms, again, the x and the x, I should have put that in green. The x to the first and x to the fourth, those can be combined with multiplication, and the y to the first and y to the second can be combined. So this is 16 times x to the 1 plus 4 times y to the 1 plus 2. So our final answer is 16 x to the fifth y to the third. There's our final answer. Let's do another one. Okay, now in this case we're multiplying a monomial, but now it's multiplying by a binomial. Now in this case you need to use your property of distribution. You've done this before. The x cubed is going to get multiplied by the negative 3x squared, and then it's also going to be distributed to the x. So when we write this out, we're going to write out, this is, let's do this, yeah, we'll do it over the side. This is equal to x cubed times negative 3x squared. And then we're also, since x cubed is positive, we're going to also multiply x cubed times x. And now we can just go ahead and do what we did in the last two. We'll multiply monomial times monomial. This has a 1 in front of it. It's implied because you don't have to write that in math when we're multiplying. So 1, the coefficient of 1 times negative 3 is negative 3. And then we have x, and the exponent is 3 plus 2. There's a 3, there's a 2. Now we're going to add to this. We've got x cubed times x, that's just x to the 3 plus 1. Remember, we have an implied 1 here. This exponent on the x is just 1. Now we'll go ahead and wrap this up. So we've got negative 3x to the fifth. Let's write that a little bit neater. Negative 3x to the fifth plus x to the fourth. And there is our multiplied monomial and binomial actually. And let's do one more. We've got a monomial and a trinomial. Now don't be thrown by this, class. It doesn't matter. Notice here the monomial was in front. Here the monomial is in back. If you don't like that, you can just move it over to the front, but we can distribute backward as well as forward. So in this case, you can distribute the 2x squared to the first term, and the second term, and the third term. So let's go ahead and write that out. This equals, we've got 2x squared times 3x squared plus 2x squared times negative 6x plus 2x squared times 10. Alright, now we just got to go through what we've already learned, how to multiply two monomials together. I'm going to move over a little bit here so we have a little bit more room. 2x squared times 3x squared, well, the two coefficients, 2 and 3, the two constants, those get multiplied together, and that's 6. And then we've got x squared times x squared is x to the second power plus the second power. We add those together. Then we've got, we got a positive 2 times a negative 6. 2 times negative 6 is actually negative 12. X squared and x to the first, this is x to the second power plus the first power. And now we've got the coefficients 2 times a constant 10, that's plus 20. And we don't have anything to multiply the x term by, so we just got x squared. Alright, let's wrap this up. This is equal to 6x to the fourth minus 12x to the third plus 20x squared. So you can see the rules of multiplying something by a monomial, either a trinomial, something times a monomial. In this case we did monomial times monomial, monomial times binomial, monomial times trinomial. You can see once you know the basic rules, it just takes a little bit longer, but it's the same process for every term. Alright, let's apply this to a word problem. This one's not a difficult one. Write a polynomial equation for the situation and then solve the problem. So writing the equation is the first part. Remember, an equation is going to have an equal sign, and then we're going to solve it. So it says a painting has a width of x minus 2 feet and a length of x feet. What is the area when x equals 9? Well, when it says a painting has a width of x minus 2 feet and a length of x feet, there's our issue of writing the equation. And then it asks you what is the area when x equals 9. That's going to be our solving. So I find it again helpful, class. Man, if you can, try to always draw a diagram, and you'll be able to see that it helps these problems make a lot more sense. So I'm going to go ahead and draw a diagram and say, okay, there's my painting. And I know that the width is x minus 2 and the length is x. Now you probably wonder, well, how did I know to put x minus 2 here and x here? It really makes no difference. I could have put x minus 2 here and x on this side. It doesn't make a difference as long as I know this is width and length. So one dimension is going to be the width and one dimension is going to be the length. It doesn't matter whether you flip these around or you label this side and this side. It doesn't make any difference. Alright, well, let's figure out. You should remember this from a previous class. Area of a rectangle is equal to length times width. Some of you may have learned this as base times height. I'm going to suggest you rethink that as length times width. The reason why is later when we get to volume, you're going to see that base is going to mean a different thing to you than you've learned before. So I'll just use area equals length times width. Well, which of these is length? Again, doesn't matter. I'm going to go ahead and just pick, I'll pick the one that they labeled as length as x. So length is x and width is x minus 2. Well, this looks familiar. Here is a monomial times a binomial. Let's distribute. X is going to multiply times x. X is going to multiply times negative 2. So x times x is x squared. Remember, x to the first power plus 1. So x to the 1 plus 1, which is x squared. X times negative 2 is negative 2x. So we just found the first part of our question. Here is our polynomial equation. This equation represents the area of this painting. Step 2 was to find the area when x equals 9. And mathematically, here's how I usually write this. You're going to put on here, on this part, x equals 9, and you're going to go ahead and put a colon here. That tells you that the next part of your work is showing me that the answer for the area is going to depend on when x equals 9. So let's go ahead and solve this. Our area is going to now be 9 squared minus 2 times 9. Now, a couple things I want you to notice here. We are now doing something called evaluation. We're evaluating this equation when x equals 9. Okay, next thing you notice is wherever x was in the equation, I plugged in the 9. And the third thing I want you to see is always input that in parentheses, because now you can go ahead and pull up your calculator and put this actually in your calculator. Let's do that right now. We're going to use parenthesis 9 close parenthesis, then we'll do squared minus 2 parenthesis 9 parenthesis. So always put variables in parentheses when you solve an equation. When I press equal, that is 63, and our answer to the area when x equals 9 is 63. Our unit of measure is feet. 63 feet, and remember, area is always squared units because area has 2 dimensions, so the unit has an exponent of 2 or squared. So the area when x equals 9 of this painting, is 63 feet squared.